Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Musakim and I will demonstrate how to construct the simulation for activity 1. Okay, first we have here 12 volt for DC power, 3 mechanical switch S1, S2 and SG, 1 resistor 4.7 k ohm and 1 SCR and 1 lamp. The lamp that I use is virtual lamp, so that it can turn on and turn off during the simulation. So at from 12 volt DC power, it connect to the switch 1. From the switch 1 we connect to resistor, to the SCR, to the switch 2. From the resistor will connect to SG and connect to the gate of the SCR. From the S2, it will connect to the node between the SCR and the lamp, and the SCR will connect to the virtual lamp and ground and connect to the negative part of DC board. Okay, that's all from me. Thank you.
Assalamualaikum and hello everyone. My name is Anas bin Muhammad Ghazali. My metric number is CA200109. Today I will be explaining about Silicon Control Rectifier SCR with switch. Okay, so first of all, we need to construct this circuit. To make this circuit, we need all these components. The first one is a VDC, a voltage supply, DC voltage supply with 12 volt. After that, a switch and a variable resistor, 10 kilo ohm. And after that, a resistor with 4.7 kilo ohm and another switch. After that, the load. The load can be anything, but now I will try use a bulb because it can show the effect much more better. And finally, the most important one is the thyristor. Okay, so this is the thyristor. Okay, before you construct the circuit, always remember to turn off the supply so that no incident will happen to you and the component. Okay, now after you're done constructing the circuit, okay, we're done constructing it. First, we will need to close the S1. Then turn on the power supply. Okay, so we can see the ammeter and voltmeter here. So here the ammeter is 1.57 microampere, which is very small, close to 0. And here is the voltmeter, 12 volt. This is because the circuit is like an open circuit. There is no load in the circuit. Okay, now we will close the G switch here. Okay. When we close the G switch, we can see the light bulb here. The lamp will turn on, and even if we pull up the switch here, G switch, the bulb will still turn on. This is because after the thyristor gate here is given supply current, it will trigger the thyristor and will allow work to pass through the circuit and press the load. Okay, now we will increase the variable resistor, but here we can only increase by 5% each time, so we can't do 1%. Now I will increase by 5. Okay, you can see that the lamp instantly shut down, and the current is also reduced to 21.73 milliampere, and the volt also reduced to 821.93 millivolt. This is because the thyristor does not receive enough current, so it will close the circuit back. Okay, now here we can see here, this is the holding current of the thyristor. That means if it's this value, the thyristor will trigger and deactivated. Okay, so we need to make sure that the value of the variable resistor is correct and the amount of current flow through the thyristor is enough so that the circuit can be flowed freely. Yeah. Okay. That's all from me. Thank you for listening.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ainur Maisara binti Ahmad Faris and my metric number is DE190187. So for this part, I will be presenting the activity number 3, which is the phase control. Let's get started. Okay, first, we need to construct a simulation by using multisim by featuring the figure 4.3. So first, we need to put the V source, which we use the V peak, and then we set it into 12 V peak and 500 Hertz at the 0 degree. And then we put the R1 with 470 ohm, and then we put the R2, which is the variable resistor, with 10k ohms, and then the capacitor we put the value of 0.33 microfarad, and then we choose the diode 1DH62 and the SCR 2N15695, and then the virtual lamp with 12 volt. I put the oscilloscope here, and then the channel A, I connect it with the input, and then channel B I connect with the output. For the multimeter 2, I put it at the output, and then the multimeter 1, I put it between the R1 and the virtual lamp here. Okay, so when we start the simulation, we run it, and then the first thing that we can observe is the virtual lamp are on and off, which means there are currents are flowing in here in the circuit. So now let's take a look at the value for the multimeter 1, multimeter 2, and the oscilloscope. Alright, now we pause it. We can get the value for the I out for DC is 230.329 milliamp, and then the value for the V out DC is 3.317 volt. And then if we see at here, I set the channel A as the input, so we use AC, and then the channel B as the output, so we put the DC. So there is where we can get the sinusoidal for the output and the input. We can get that the orange one are the graph after the SCR are triggered, and then the red one are the input itself. So now it is at the variable resistor at 0%. So now let's take a look if we move it to the midpoint. The minimum point is 0%, and then now we need to move to the midpoint, which is I set it to the 45%. So at the 0% itself, there is no alpha angle at here. It is both as the output and the input are started at the 0 together, but there is a bit move. If we can if we take a look at more close up, we can see that there is the orange one are a bit to the right of the red one. So now we change it into the 45% for the variable resistor. Now we play. Okay, so now we can get the I out for the DC is 132.78 milliamp, and then the V out DC are 1.912 volt, which is we know that the current are lower than before. So the value for the current and the volt also lower than when the variable resistor at the 0% state. So now let's take a look at the oscilloscope, the graph, and we get that the orange one are moved more righter than the red sinusoidal. So if you want to know that between this here and here, this is what we call as the alpha angle. This is the alpha angle which we need to know at which time that the SCR are triggered. So next, if we move to the maximum state for the variable resistor, which is 100%, and then we run the simulation, we can get the value for the I out for DC are very little and very smaller, which is 11.006 nanoamp, and then the volt V out DC is 158.482 nanovolt. Now let's take a look at the oscilloscope and the sinusoidal generated here. I mean the graph generated here. I'm sorry. So if you take a look at the output, there is no angle. It is straight line at the x-axis here, and there is no angle because the SCR doesn't work and didn't trigger. It is because the SCR only activated at the variable resistor below than 50%, which means that when the variable resistor are more than 50%, there is no current, or that there is very little current that are run and move in this circuit. So that's all from me. Thank you.
Hi, my name is Chimpaka Amalin binti Mahaze. My meter number is DA190193. Today I will be presenting about the result of the simulation for activity 1. This is the circuit for activity 1. This is switch S1, this is switch ST, and this is switch S2. Based on table 4.1, we will see the lamp status for SCR power switch circuit. Then, we will simulate the circuit. Based on table 4.1, the first condition, S1 and SG need to be open so that the lamp stator will turn off. When the switch 1 is closed and the SG open, lamp still off. When S1 remain closed and SG will be closed, the lamp will turn on. But when the S1 remain closed and SG open, the lamp will turn on. After that, when S1 will be open, the lamp will be switched off. And that's all for table 4.1. Next, we will use S2 based on table 4.2. Simulate the circuit. First condition, all the switches need to be open. When all the switches open, the lamp status will be turned off. When the switch S1 closed, the lamp still in off. When the switch S1 and switch SG close, the lamp will turn on. But when the S1 remain closed, the SG open and the S2 close, the lamp still on too. But when we close the S1 and open both S2 and SG, the lamp will turn off. And that's all for activity 1. Thank you.